Welcome to the new cyber frontier, bringing you the latest news and initiatives that focus on the development of cybersecurity economics. You don't have to be a computer or cybersecurity expert to get plugged in. Your host brings it straightforward, asks the tough questions, and brings the cyber world to a level of understanding for everyone. You can find us on the web at www.newcyberfrontier.com. Now join our host as he introduces the topic for today's new cyber frontier.
Hello, everybody. My name is Timothy Montgomery, and I'll be your host today for New Cyber Frontier. Today we have guest Joe Weiss. Sir, how are you doing today, sir?
How are you?
I'm good. If you would please introduce yourself and give us a little summary of your background.
Okay. Again, my name is Joe Weiss. I'm a control system engineer.
Awesome.
And I work on cybersecurity of what are called industrial or other types of control systems. So these are the things that run power grids, refineries, pipelines, water systems, manufacturing facilities, railroads, ships. All of these types of things that our economies and life depend on.
That's right. Central systems in the world, right?
Mm-hmm.
What we call modern class civilian.
Yes, and if you don't have them, we're back in the 1850s.
Pretty much, right? Way back. So it was in the Stone Age, basically, is what they say.
Yes.
Well, that's interesting. Control engineers. So control engineers, they don't, basically we don't hear a lot about control engineers and how control engineers actually have an implementation in cybersecurity, do we?
No.
I don't see that being on the front end of every cybersecurity newspaper, right? So
No. Yeah.
in your field, you do a lot of back-end embedding and engineering to support mechanisms that may take a utility system and improve on it, right? Is that kind of what the concept is?
Part of the issue. In fact, let me take you back to a funny thing you just brought up.
Okay.
Cybersecurity is taught in computer science.
Mm-hmm.
There's almost no universities, and I use the word almost, that require people taking computer science to take an introductory course in engineering.
It's true.
So guess what? You're going on and you have absolutely no idea what in the world is going on.
Yeah.
Conversely, again, not always, but in most cases, none of the domain engineering disciplines, electrical, mechanical, civil, chemical, nuclear systems.
Yeah.
Most of them have absolutely no requirement to take an introduction to cybersecurity.
You're absolutely correct, as far as the curriculums I know about.
And so here we are. You keep hearing about this IT-OT convergence. It's exactly opposite. We couldn't be diverging more.
That's interesting. So what makes you think, what kind of brings you to that conclusion? I don't know, with all the things you've probably seen so far as where we're headed for what this means. This brings up, in my mind, the Internet of Things, right? That's kind of what it brings up for me. The idea of being able to connect this technology, have these sensors and things that, feed into information that supports the activities of a system as a whole. And then, of course, implying that security to it, which we know the vulnerabilities today of Internet of Things, essentially. So I don't want to go off topic too much, but I realize they kind of have connecting values in there somewhat. So,
okay, well, you brought it up. There's a kind of a running joke, which is, where is the S in IoT? There is no security in IoT.
Yeah, you're right.
Now, the point being also, the term IoT is very, very, very misleading. You're in Houston, you're in the middle of the oil patch area.
Yeah.
We've been connecting systems since probably mid to late 1990s. There's nothing new here. We're
Right.
just lousy marketers as engineers. And the concept of IoT never came around.
Good engineers, bad marketers.
Yes. It was the same thing with smart grid.
Yeah, I got you.
Okay? So the point being that one of the things about control systems, and by the way, IoT, there's IoT and there's what's also called IIoT, Industrial Internet of Things. Because when people talk about Internet of Things, they're thinking about Fitbits and refrigerators.
Yeah, they are. Here, LG
Okay.
refrigerator, right?
We're talking about power plants and pipelines.
Yeah,
They are really, really, really different.
I can
And
only.
if something happens with your Fitbit, people don't die. When something happens to a pipeline,
Yeah,
people die.
yeah. And it usually means a halt in some type of economic value too, right? So the impact there as well.
Now, the issue here is that, like I say, these are engineering systems. And cyber has never been really part of the engineering systems. What's part of it? To be very reliable, to be very safe, to be efficient. Secure just wasn't one of those requirements.
Yeah.
Now, the point being, you had asked about the IEEE privacy. Other than a meter that has customer data on it, essentially, we don't care about privacy or confidentiality.
So there's really no impact privacy.
Actually, there's a negative impact
Is there?
because people want to put in all of this security to protect against, privacy.
I see.
And they actually impact the operation of a control system, which was never designed for that.
Well, on that thought, we're going to have to go to break. And so when we come back, we will talk more to Joe Weiss about how we believe the cybersecurity elements that are being worked today may have a massive impact. So let's take a brief break and hear from our sponsors, and we'll be right back after that.
Cyber Resilience Institute helps build strong cyber communities designed to prevent members from attack. Like building a neighborhood watch, it takes coordination and a sharing community to protect our identities and valuables in the virtual world. Typically, we hear that organizations know they need to do something to protect their cyber assets, but don't know where to begin. Let Cyber Resilience Institute help your community create an action plan. Cyber Resilience Institute will build your community or business marketplace so that it is designed to support a collective cyber defense. Contact them for more information at cyberresilienceinstitute.org.
Welcome back to New Cyber Frontier. I'm your host, Timothy Montgomery. I'm here with Joe Weiss. And before the break, we were just discussing how the implementation of such elements for cybersecurity and privacy compliancy measures can have a negative impact to such as utility systems. And Joe's been in the field for a very long time doing cybersecurity on utility systems and the water and different systems that we rely on every day. So Joe, you were saying that you believe that that it actually could have a negative impact to try to imply such things as privacy controls to such systems that don't really require them, right?
Yes. And the point being, these systems, number one, they have to work, and they have to work all the time. Number two, they have to work in a very, 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 very short, defined period of time. And if they don't work in that short, defined period of time, you've effectively done a denial of service.
Yeah.
When you start trying to put in all of this stuff for privacy, you're slowing the system down. You're almost doing what the hackers want to do.
That's true. It can inadvertently cause the denial of service.
There has been any number of times where IT has caused more problems than hackers.
So you do some blogging on the side, a lot of that, or
Yeah, I do it on the side.
yeah, you do it full time?
Pardon?
You do it on the side.
Yeah.
So you were talking about, I know we had a conversation there right before we started all this craziness here. You were talking about something you had and you were putting out for a blog. What was the title of that thing?
Well, the title is going to be U.S. critical infrastructure cybersecurity is backwards. It's the process that counts, not the data. You know, today, President Biden issued a national security memorandum.
Yeah.
Well, let me start with this. In 1998, President Clinton issued Presidential Decision Directive 63. This is in 1998.
98, yeah, I remember that.
It was supposed to be for cybersecurity of the infrastructures. We're now in 2021. And
More than 2 decades, right?
arguably, they're not a whole lot better secured than they were in 1998.
There's a lot of truth in that. We ultimately are not.
Now, so number one, politically, this isn't a Republican or Democratic problem. This has gone through how many different presidential administrations, and we still haven't gotten our act together to secure these systems.
That's true. I mean, you're talking about 2 decades worth, at least 3 presidents, 4 presidents there.
And so this is, I want to right up front get across that there is nothing political about this.
Well, that's
and,
right.
You know, can you bring the grid down for 9 to 18 months just via cyber? Today, the answer is yes.
So you're talking about cyber attack.
Addressing those specific issues? No.
Yeah.
Are we addressing the issues like ransomware that can take you down for a couple of hours to a couple of days? Yes. Do you notice a disconnect?
Yeah, it sounds like their priorities kind of not quite where they should be, right?
The biggest problem we have, I just earlier today was on another podcast, is culture. The network security people don't like and won't work with the engineers. The engineers don't like and aren't really that interested in working with the network security people. It isn't possible today to secure anything. The issue also, I'm sure you've heard the term OT, operational technology.
Yep, ITOT.
That term came because Gartner didn't know what a control system was. This was their way of trying to get rid of it by saying, if you're not IT, which we know all about, you're OT,
yeah,
which is something else. And unfortunately, that really, really bad, lousy term, I'm sorry, has stuck. Now, the issue is, again, you can never say never, never say always.
right.
Most people who consider themselves to be OT are basically, I hate to use the term, rebranded IT people. Most engineers, you know, the turbine engineer, the relay engineer, the instrument engineer, the manufacturing engineer, safety engineer, most of them never even heard of the term OT.
That is interesting.
They're engineers.
I know.
Yet you have all of this stuff about this IT-OT conversion. This has nothing to do with networks. That's all that is just networks.
Yeah.
The actual turbine or pump or valve or relay or transformer, That's not in the purview of anybody in quote unquote OT. That's the engineers.
Yeah.
Well, the engineers, again, never say never, never say always, but in all too many cases, have been excluded, explicitly excluded from the world of cybersecurity. Now, it's kind of crazy. How can you secure a pump when you don't even know what the pump does?
That's true. I mean, I could see where if you don't understand what you're
Yeah.
securing, how can you understand how to secure it?
When you talk about the CISO, the Chief Information Security Officer,
Yeah.
you can probably count on, I don't know how many hands, how many of them have ever seen a pump, a valve, or a relay?
Now you're taking it from the engineer's perspective.
Well, my point is, whose equipment is it?
They're the owners. Ultimately, their responsibilities.
Yeah, well, that's the point. You know, how would you like to go in for a heart transplant and they're going to have the IT network expert do the transplant because they're the ones putting together the communication into the operating room?
Yeah.
That sounds silly, doesn't it?
Yeah, it does.
That's where we are with the grid.
Yeah, that's okay. Yeah. That's interesting.
And by the way, that's where we are with pipelines and water systems. And you can keep on going.
So what do you believe some of the remedies? You know, if I had to give one thing or two things, I would say as a cybersecurity expert, what's going to solve some of these equations?
Two things. The first is the vice president of engineering or the vice president of power production or refining must be on the cyber policy making committee and also reporting to the board. They're almost never.
Yeah.
Who's doing it? The CISO. As long as that happens, there is zero chance that you are going to secure anything on a critical infrastructure. Zero.
Yeah.
Okay. Period. The other is, these are engineering systems. They need an engineering solution. What happened over the weekend, and the reason for the blog I'm about to put out, was the Israel Water Authority just awarded, quote unquote, a contract or whatever, however you want to phrase it, to a small company to secure all of the Israeli water systems. What are they going to do? They're going to be looking at the process sensor measurements, not the network. That is the reason for the blog. Why do you want to secure a water system? So the water system works.
Yeah, without.
What are we doing here? We're not trying to secure a water system. We're trying to keep the network up.
Yeah.
Which, when in 2015, when the Russians cyber attacked the Ukraine and turned the lights off, when the lights came back on, the Ukrainians ran that grid for at least 6 to 8 months with no networks.
Yeah.
Why? They couldn't trust them.
Yeah, they weren't going to put it back on the network.
However, as long as the control systems were working and operable, they could run the grid. If those control systems and sensors aren't working, there is no grid. And by the way, if there's no grid, there's no internet.
So are they working on some type of new technology that would?
Yeah.
I mean, what type?
It's not even new technology. It's the only thing that's new.
Yeah.
Is, if you will, the machine learning, et cetera, that's involved. They're doing now what I was doing. I'm actually a nuclear engineer. It's what I was doing, a whole lot of years ago,
Yeah.
even before we called it cyber.
So you
You're
think
looking at the process. You're looking at the sensors
yeah,
and basically determining, are the sensors working right? In other words, is the process working right or not?
yeah, QA.
No, it's not QA.
No?
No, this is how you monitor a refinery, a pipeline, or anything else. In a sense, you're looking at the gauges and making sure the gauges are telling you what the gauges should tell you.
Yeah, essentially.
And as long as they are,
Actually doing
guess what? You don't have a problem.
Yeah.
So, like with ransomware, part of the reason I got so interested in this particular company was I actually worked with and for them for several years. They did a project at a large water system.
Yeah.
And they were monitoring the sensors, and they had an offline sensor monitoring program where they're looking at the electrical characteristics, the physics of the sensors. Well, guess what? You can't hack physics. Well, while they were doing that monitoring, the Windows-based HMI, the Windows-based SCADA system, went down. This is your OT network. It went down. Now, it wasn't hacked. It could have been. Didn't matter.
So what was
It lost the OT system. What happened with Colonial Pipeline? DHS and everybody else was paranoid that somebody would get to the OT system.
Yeah.
Well, they lost the OT system. This offline monitoring system that was looking at the sensors kept working. That's how they knew everything was okay. And guess what? Neither ransomware nor any other IT network malware, none of them can get to this.
Yeah, it's because it's isolated after that, right? I mean,
it's sitting there, and basically something like this is the only way you can justify to continue operating, regardless of what's happening, at the network layer, whether it's ransomware or anything else.
So this gives you back to why you think they're just trying to keep a network up, really.
Well, the point is this. My analogy is, you're driving your car, you're at 80 miles an hour, you have a flat. You replace it with your little run flat spare. Well, you can't keep going 80 miles an hour. You're going to go 40 miles an hour until you can get it to a repair shop and fix your regular tire, put it back on, and you go back to 80 miles an hour. But by having that run flat, or by being able to monitor the actual system in real time, you don't have to shut down. Is it operating as efficiently as you would if you had all of the networks? No. But all of a sudden, you don't have to be JBS and shut down every meatpacking plant they have.
Yeah.
Colonial was a real problem independent. But the point is, with this, from that perspective, you wouldn't have had to shut down. They did something that was crazy, but I won't go into that. But when you look at, like even with NotPetya or whatever, all of the assembly plants that were shut down, all of these facilities that were shut down under a quote unquote abundance of caution.
Yeah.
You didn't have to do that.
That's interesting. Okay. So let's pause right there for a commercial break. More interesting things as we come back from the commercial break. So everybody stay tuned. We're talking with Joe Weiss here on control systems and utility systems, aren't we? So we'll be right back after these short advertisements from our vendors. we're back from our break. This is New Cyber Frontier. I'm your host, Steve Cummings. We're here with Joe Weiss, Control Systems Engineer, cybersecurity expertise. And we were talking about how, I guess, standalone systems and their control measures don't necessarily need to be implemented as long as there's efficiency. So we don't need to go running, like the sky's falling. I guess you can call it Chicken Little, really, a little bit, and implement such stringent standards that would slow the industry down, but necessarily would allow for the purpose of once the control system itself, not necessarily the utilities, the water systems that would work or electric systems that would work, they would still continue to work. And they would just continue to work until the systems that were monitoring them came back up to start taking more metrics, right?
Yep.
So essentially, that's one way to make sure we're still using security systems like your OT you're referencing before, left for the break, and the implementation for good security values and an actual posture for security monitoring. So, I mean, the value that brings, the impact is very minimal. I mean, what makes you, I guess, lead you to kind of, why do they shut down systems like that? I mean, why are they doing that if really all you need to do is reboot or reestablish the network connection with this system that monitors, not necessarily everything else?
Number one, like what happened in the Ukraine,
Yeah.
they couldn't trust that the system wasn't still compromised.
Oh, that's right. You did say that. The trust.
There's no trust. The fundamental point is what you do for IT is different because IT is the network and nothing but the network.
Yeah.
In any operational environment, whether it's electric, water, oil, gas, even say the building controls in a hospital, a ship, anything, that is, you are essentially manipulating physics to run, to make power, to make product, to do something.
Yeah.
Okay. We were running power grids for 80 years before there was ever such thing as an IP network.
Yeah, you're right. Yeah, those continuous measures are still pumping wire.
And what's happened is the IT world has stepped in and tried to claim a domain that simply isn't theirs. And they have caused more problems than you could shake a stick at. And that is even showing up in what was just put out today, because, with this national security memo, because it's not dealing with the actual control systems, it's dealing with the networks.
Yeah.
And we have to figure out what is important. Is it keeping lights on, water flowing, pipelines intact, trains from not crashing?
Yep.
Or is it making sure somebody can get whatever bits and bytes? That's secondary.
Yeah, it would be the secretary.
We have the tail wagging the dog. And until we get people to recognize this is wrong, we're in trouble.
Yeah.
It's really that simple.
So, like I said, well, how do you bring those priorities? Because right now, as it is, they're trying to standardize the OT into different privacy practices and the NIST standards and standardizations.
I know.
The impact it's probably going to have on the operational pieces of, is there a trend there that you see that's going to be a massive blow or it's not going to be effective? And how do we know that's going to happen?
Here's what's interesting. Here we are in the middle of 2021. We have no cyber secure, authenticated sensor measurements of things like pressure, level, flow, temperature, voltage, current, motor speed. None anywhere, period. How in the world do you think you're going to secure anything when you can't even trust what you measure?
I think, well, I at least thought, well, I worked for Schlumberger, we'd been able to calculate, but the equipment that was taking on all the parameters.
Yeah, but you know what you did as Schlumberger,
Yeah.
which is what everybody is doing. They assume the sensors are uncompromised,
Yeah,
authenticated, and correct.
I got you.
Okay.
That's interesting. So would a thing like blockchain solve such an issue?
No,
No.
what we're talking about is, and DHS, S&T, and everybody else has missed this. Every single OT monitoring, whether it's Clarity, Nozomi, Dragos, you name it, they all assume the sensor measurement is fine, okay, and coming from there. And then once it's converted to a packet, they're able to monitor it from there.
Yeah.
But until it's a packet, they have no idea.
Right.
at
So
all.
anything could go into the packet.
The Chinese have installed in at least one transformer. We're talking a 500-ton electric transformer. Hardware backdoors.
Yeah.
Okay. As a result of that, the next large Chinese transformer that arrived in the port of Houston was intercepted by the Department of Energy and sent off to the Sandia National Laboratory. There's a utility missing a 500-ton, multi-million-dollar transformer that takes a year to build and get. Now, the reason I'm bringing this up, there's actually a presidential executive order on this.
Yeah, I figured it was.
But the industry turned it around.
Yeah.
What the Chinese did was put in this backdoor so they could send spoofed, in other words, signals to the transformer to have it do whatever they want it to do.
Yeah. It basically,
well, guess what?
Lying to you.
But you know what our industry has done? They said, we're going to go do software quality assurance for software supply chain. Excuse me, the Chinese just did a hardware problem. And they're just basically saying, well, since that's not what we do, that doesn't count. Now, the issue is very fundamental. They bypassed every cybersecurity measure you have.
Yeah.
And because I told you before, we have no authentication. Without some of this new technology I'm talking about, you have no way of knowing, did that voltage signal going to the load tap changer inside the transformer, did that come from the voltage signal in the transformer, or did that come from Beijing?
You don't know.
That's my point.
Yeah.
The load transformer doesn't care.
Yeah.
Or the load tap changer, excuse me. All it's saying is, what's the voltage and what steps do I need to take? You know, the same thing with the protective relays.
Yeah.
They're not asking, where did that voltage or current or temperature signal come from? They're simply saying, here's the signal. This is what I've been programmed to do.
Well, that's a very unique perspective. We're going to have to wrap the show up here, Joe. It was very interesting chatting with you. I'm glad you kind of opened my eyes to some of that. I hadn't realized from that perspective myself. It kind of nudges you in a way, and you feel like, well, you're right. I mean, they're protecting to a point, and then they really don't care beyond that, and that seems to be the part they're missing. So if you got to our audience before we go, do you got anything particular you'd like to say to them?
Other than, number one, thank you. Number two, you might find my blog site of interest, which is www.controlglobal.com/unfettered. And I am an independent consultant if there's, a need or whatever, but There are very few people in the world who are addressing this.
Yeah.
Period.
No, you're right. And there's a real need for this now, perspective wise. I can see where they're missing the piece. So definitely true. Well, great. It was great talking with you, Joe. I hope we get the chance to meet again and have a handful of more podcasts, if you will. I did get a chance to see your blog, your website, Unfettered blog, and I'm looking at it now. It's interesting. I've got some of the other components. I was reading through some of the ICS and some of the other control elements in here. So I'll be sure to jump on there and see what you got to offer for your blog.
Yeah. One other point before I lose you. This is the book I wrote. I don't know if you can see it or not. Called Protecting Industrial Control Systems from Electronic Threats.
So you co-author those things, or
I wrote it.
Wrote it. Okay.
About 10 years ago. There's at least some universities using it as required reading.
Yeah. I'll be sure to check that out.
Yeah, I have a database, I'll leave you with this, of almost 12 million actual control system cyber incidents. There's been over 1,500 people killed and well over $90 billion in direct damage to date. And you haven't heard of hardly any of these.
Wow.
Because we don't have control system cyber forensics below the Ethernet level.
Interesting. Well, Joe, thank you for coming on. And like I said, I hope to see you again. And so
sounds good. Thank you for the invitation.
No doubt. All right, that marks the end of our podcast for New Cyber Frontier, and this session's gone. I am your host, Timothy Montgomery, and it was great to host for you today. And next time we'll see you on New Cyber Frontier. Have a good day. Bye-bye.
Bye.
Let me stop.
We hope you have enjoyed this episode of New Cyber Frontier. Remember to get involved. Often we think that someone else will handle privacy and security in the virtual world, but you are the only one truly in command of your virtual fate. Join our mailing list so we can keep you informed of breaking news and new releases. If you have an idea, if you have a question that you would like to hear answered, or if you want to get involved with our efforts, reach out to us at newcyberfrontier.com. We also encourage you to visit our sponsors' links, as they are the ones that really make this show possible. I want to thank each of you for supporting the show, and we look forward